Okay, so you have the handout in front of you. I see a lot of you have already kind of filled it out. We have two different properties that we're going to talk about. One is properties of equality and one is properties of congruence. And again, like the quick word asks you to do, equality is more quantities, numbers, values, and then congruence is going to be our shapes. All right, there's going to be a lot of similarities between the two. All right, so you have this handout. This is the first half of it. And we have the addition property of equality. So it says if A equals B, then A plus blank equals B plus blank. What has to go in the box? We can put a C. Could I put a D? Yeah. Could I put an X? Yeah. Could I put a pumpkin?
Yes.
Sure. As long as I do one thing to one side, it has to be the same on the other. So we say in general, it's got to be C and C. All right. Subtraction property, same thing. If I take away a number from one side, I have to take it away from the other side. So my subtraction property of equality. Multiplication. If A equals B, then A times something equals C times something. All right, pretty straightforward. The next one has a little bit more to it. So if A equals B and C is not equal to 0, then A over C equals B over C. Who can tell me why C can't be 0? Can't divide by 0. Can't divide by 0. Who can tell me why you can't divide by 0? What? Who can tell me why you can't divide by 0? Sean?
Because it's infinity.
Why is it infinity?
Because there's the upper number, the bottom number is 0, the upper number, no matter what it is, will be infinitely larger, like multiplication rules. Like, it'll just, you can't, like...
You're getting there.
It's there.
I like the effort. Yes, really.
Are we thinking of turning this into you or just...
This is your notes. This is your notes.
I'm right, right?
It is infinity, but why is it infinity? If I have 10 fingers and I divide 10 by 2, what do I get? 5. Because I can make 5 groups of 2. If I have 10 fingers and I divide it by 10, what do I get? 1, because I have one group of 10. If I have 10 fingers and I divide it by 1, what do I get? 10, because I have 10 groups of 1. If I take 10 fingers and I divide it by 0, how many groups of 0 can I make?
0.
I can make 0. Can I make one group of 0? Uh-huh. If I was to divide you guys up into groups of 0, and I put one group of 0 back there, one group of 0 here, one group of 0 there, one group of 0 over there, is there any limit to how many groups of 0 I can make? No, because I'm not taking away from the quantity. So that's exactly what Sean is saying. We often talk about it's undefined or infinite. I can make as many groups of 0 as I want. Okay? So we say we can't divide by it. All right. The reflexive property of equality. A equals A itself. Okay? It's tempting to read more into that than you think, but it's true that A equals A. Very straightforward. Symmetric property, if A equals B, then B equals A. Now, we know if we have a conditional statement, that's not always true, that we can turn it around. But if things are equal, the order is not important. A equals B, B equals A. All right. This one we use all the time, the transitive property. So, if A equals B and B equals C, then A equals C. This is really similar to our law of syllogism. Right? I could conclude if I told you that Sean is the same age as Peyton, who is the same age as Chad, what do we know about Chad and Sean? They're the same age. It's the transitive property of equality. If they're equal and they're equal, those two have to be equal as well. All right? Substitution property. If A equals B, then B can replace what number in any expression? A. All right. Where did it go? And then the last one, the distributive property. If I have something outside the parentheses multiplying, I want to distribute that through. What do I get if I was to distribute that A through? Alex. Yep. AB plus BC. You got to remember you give it to everything in there. So you have multiplication outside, it goes through to everything in the middle. All right. Thumbs up if it's easy. Should be. Good. Let's talk about the difference between properties of congruence. There's not much difference except now I'm talking about shapes. I'm talking about angles, I'm talking about line segments. So the reflexive property, line segment AB is congruent to what? Line segment AB. Angle A is congruent to angle A. The symmetric property of equality, line segment AB is congruent to line segment CD. That means that CD has to be congruent to AB. And then if angle A is congruent to angle B is congruent to angle A. I know. It's tough. And then the last one, the transitive property, the one that we use the most. If AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. Same thing with the angles. We conclude that angle A is congruent to angle C. Alright, so let's look at how we use this. Here's an example. Does this look like a familiar picture?
Yeah.
Yes, we've solved stuff like this. We've done the math, but we haven't explicitly talked about why we can do it. So if I'm given AC bisects angle BAD, who can tell me a conclusion that we can draw from that given information? Yes, Shelby.
Angle BAC and CAD are congruent.
Good. So if we solved it, the measure of angle BAC is congruent to the measure of angle DAC. Now, Dad, if you agree with that statement. We did. We should. All right. My next step, I want to plug in 2x plus 1 and x plus 4. Well, now we have an equation. We think back to algebra class. I want to get the x's on the one side, the numbers on the other. Who can tell me what step I take to do that, Alex?
You subtract x from this side that it's on before, and you subtract 1, so x equals 3.
Good. And I subtract 1 and get x equals 3. All right. This is where this class gets different than you've done it before. I need to know why I'm allowed to do any of that. We need to explain why that's okay to do, besides your math teacher told you. So if we look at the reasoning, bless you, / justification. Why? Who can tell me why measure of angle BAC is equal to the measure of angle DAC? Alex, what do you think?
Addition property?
Not quite. Yeah.
Substitution property?
Not quite.
How much one?
Why is this first line true?
Symmetric property.
It's given. What's given?
M angle BAC equals M angle B. Because it's bisected.
It's given that it bisects it. What does a bisector do? It cuts it into two congruent pieces. So this is given by the definition of an angle bisector. So if we have an angle bisector, we have two congruent angles. That's what an angle bisector does. All right? How do I get from this thing to the next line? What am I doing? What rule am I applying? Ellie?
You're substituting.
Substituting. I'm allowed to do that because we have the property of substitution. And then I get rid of the x's because of the subtraction property of equality. That allows me to subtract the same thing from both sides. I simplify, so I combine like terms. And then I apply the subtraction property of equality again. And I simplify. So that's what's going on behind the scenes when you're solving equations. You're applying these rules, you've been doing them for a long time. But now we want to flesh out the why. Why can you do this? So you're going to have to justify your steps. This is a proof of why this is true. Thumbs up, sideways, or down. That would feel okay? It's the same mechanics, it's just putting reasoning next to it. Alright, I want you guys to do two things. Solve this. Oops, need more information. You're given that AC is 30. Solve it, and then try to think about why can you solve it the way you solved it. What are the rules that you're applying? And take 2-3 minutes, and we'll talk about it.
Okay.
You can work with those around you. Feel free to do one. I see that a lot of people have an answer for X, but now they're struggling with the reasoning. And I bet you're struggling with the first step. Right? So this is where this class gets a little bit hard for people in that we don't just need to know the math, we need to know why we're allowed to do it. So if we think about the first step, AB plus BC equals AC. Not yet, you had that step somewhere. Good. All right? And then we put in the values that we were given, and we solve it. I get X equals 4. So now we need to go back and figure out what was my reasoning. How could we do this? Well, the first one is the trickiest. So our reasoning. This is a postulate from chapter 1 that we talked about that when I put it up on the board, you thought it looked really simple. And it is really simple. Called the segment addition postulate. Now remind me, what is a postulate again? Very nice. Something accepted is true. And the segment addition postulate says exactly this. AB plus BC equals AC. If I have 3 points, this piece plus this piece equals the whole piece. We accept that to be true. That seems to make sense, right? There's our reasoning. All right. Who can tell me how I get to the next step? I went from line segments to something with variables. What did I do? I substituted, right? AB is equal to 2x. That's given. So I'm going to substitute. I'm going to take out the AB and I'm going to put in something that's equivalent. I take out the BC and I substitute in 4x plus 6. And I take out AC and I substitute in 30. So there's substitution. And then I simplified. Not yet. Oh. So getting rid of the 6 is my subtraction property of equality. Dividing by 6, it's not.
Why can't substitution be the distributive property?
Here,
Okay.
at this line.
No, why not substitution? Why can't it be distributive?
Because what I did is I took out this thing, AB, and I put in an equivalent expression, which was 2x. So I'm not going to factor out a b and distribute. I'm going to take out, I want to get to x. I want to solve for x. So I'm going to take out things that don't have x and substitute in things that do have x. We're trying to get an equation. That's a good question. My next one is my division property of equality. And I simplify it, and I get my answer. Thumbs up? Good? All